Now we're gonna talk about the application of inductive effect in order to determine the acidic and basic strength. We need to figure out the acidic and basic strength using of inductive effect. So let's talk about first of all acids. What are acids? You might have learned that in physical chemistry, ionic equilibrium in brief, but let's see in perspective of organic, how do we describe the acids? Like acids are described in two parts: strong acid and weak acid. So strong acid are acid which strong acid, if we talk about, are like HCl, which totally dissociate into H plus and Cl minus. If we have taken 1 mole of HCl, it will give 1 mole of H plus and 1 mole of Cl minus. Then H2SO4, then HNO3, then HClO4. These are strong acid. Now what are weak acid? Weak acid dissociates like RC double bond O OH and dissociates like this: RC double bond O negative plus H plus. So it is a weak acid because it is a reversible reaction. So weak acid dissociates like this. So for that we define K. K tends to be RCO O negative, then H positive divided by RC double bond OH. Now this is the acidic strength. Oh, sorry. This is the weak acid. Now, what is a acidic strength? What is a acidic strength? What is an acidic strength? It is the concentration of H plus ion produced by 1 mole per liter of acid in aqueous solution. 1 mole per liter acid in aqueous solution. So if we have formic acid, HC double bond OH, and we have an acetic acid. So which will give more H plus and more O negative, more H plus. So let's look at the back. Now understand this very concentrated way. If we have an acid, this is a, first of all, reversible reaction of reversible equation. This is a reversible equilibrium and reversible reaction. So it could move forward and it could move backward. In Le Chatterley principle in physical chemistry, chemical equilibrium, we have seen when it is going forward and when it is going backward. So whenever it is going forward, it is releasing more H plus. Whenever it is going forward, it is releasing more H plus. So it will become more acidic. Again, whenever the reaction is going forward, the amount of H plus releasing is more, so acidic strength will increase. And when it is going backward, it is decreasing. So and it is going in the both direction. So when the net direction of the forward reaction is more, the acidic strength will be greater from the other one, which has less in forward direction. Or we can say K value is more, acidic strength is more, right? So when the reaction is moving more in forward direction, which factor determines that? Obviously, the stability of conjugate base. The stability of conjugate base decided of whether the reaction is going in forward direction more or less. If this anion is stable, the reaction is going in more forward direction. If this anion is less stable, the reaction is going less in forward direction. What I mean to say, if acidic strength is given, this is acid and this is conjugate base. More the stable conjugate base, more it is going in forward direction, and stronger will be the acid. That's how determine the acidic strength. So let's jump back to the question. We have this formic acid and acetic acid. Formic acid, let's say it's dissociates into Nc double bond O negative CH3. Okay, it dissociates like this. Now this is anion, and H has zero effect, and CH3 has plus I effect. So plus I effect decreases the stability of anion, and negative I increases the stability of anion. So acidic strength is directly proportional to negative I effect, or inversely proportional to positive I effect. So formic acid is more stronger acid than acetic acid. How? Because it only depends on the stability of the conjugate base, and which is an anion. So that's how we define the acidic strength. Now I am writing some acids. You have to determine which is a stronger and weak. So question is then, compare acidic strength. First, HF, HCl, HBr, HI. Second, so these are the problems while comparing the acidic strength. So you have to pause the video and try to answer it by your own, and pause the video and try to answer it by your own. So now let's discuss about the acidic strength. So during the calculation of acidic strength, we have HF, HCl, HBr, HI. So we know this the acidic strength is directly proportional to the stability of conjugate base. More the conjugate base is stronger, more will be the stability. So it's conjugate base HF minus Cl minus Br minus I minus. Now which is more stable? This is now inorganic question. F minus is small charge, negative charge. Cl minus and larger side, negative charge. Br minus small large, negative charge, and I minus small large, negative charge. F, Cl, Br, and I. So whenever charge is on different species, remember, then we will we see the signs of the element on which there is a charge. F minus, Cl minus, Br minus, and I minus. The negative charge is more dispersed, is less intensified in case of I negative. The negative charge is more intensified in case of less intensify in case of I negative, right? and it is more intensified in case of F negative. So intensity of charge is more, then less will be its stability. So HI is more stable, hence HF, HB, HCl, HBr, HI is the because I has more charge, negative charges, very equally distributed, less intensify, and more stable. Here also S minus OH minus due to more size. Here also due to more size. Here more size. Now CH4 NH3 H2 HF. Here here if you see we are going left to right. We are moving left to right. Now size is approximate. Now size is same and charge is equal -1. Then we compare electronegativity, because more electronegativity, more the holding power of negative charge. So F minus could hold a negative charge with stronger force, so it has more acid. Because when it is holding with the stronger more, it has more stability. But when size is very varying, like during the period, so we will consider the size factor. Now H2 acid HCl. HCl is more because electronegativity. Size is equal approximately because it is the third period element. Here RCH. Here it will form RC triple bond C negative, RCH double bond CH negative. All these questions are related to the stability of negative charge. Now you can answer stability of carbanion with respect to mostly in that case where the negative charge is not on carbon, then we will be see size, then we will see electronegativity. But when the negative charge on carbon, then you can directly tell that stability of carbanion. That's how you can define the acidic strength. So here it is bore acid because sp has more electronegativity than this. Ninth, 1 degree, this is 3 degree, this is 2 degree, this is 1 degree. When it is from O negative, so it has more plus I is 1, plus I here is more, and third has the most plus I. So if it is first, second, third, the largest plus I is third, so it is reducing. So first, second, third will be the acidic strength. Now let's jump to further more questions. Specifically in videos, you're gonna solve a lot of questions. There will be nothing outside this practice. You will be observing a lot of questions, right? So I'm writing more questions. Now I'll encourage you pause the video and try to answer it by your own. So now let's talk about the answers. We know again acidic strength directly proportional to stability of conjugate base. So you all these conjugate O having negative charge, negative charge, negative charge. So it is 3 degree, it is 2 degree, and it is 1 degree. So 1 degree O negative will have less positive plus I effect. So here it is. This will be the answer. Here also here negative. Cl has been minus I effect. So minus I effect is closer, minus I effect is farthest. So it is a 1, 2, 3 because acidic strength directly proportional to minus I effect, and stability of carbon is directly proportional to minus I effect. Closer the Cl, more will be the minus I, as minus I is a distance dependent effect. We have seen already in the stability of carbon ion. Here also the uh, this is alkene and this is alkyne. This is closer. Even it is less effective, but distance dominates over power. So this is the answer. Fluorine, chlorine, and this it is will be one, second, and third minus I effect. Uh, Chlorine, bromine, iodine, and fourth this is effect. Writing down more questions for your practice. You may write it with me also in your copies, or I'll be attaching the PDFs below. And if you want to listen only, you can listen. The best way is write your notes on your own. This is the best way you can understand these lectures. Now in these questions, let's first which is applying more effective on this O negative, first, second, and third. Here also, if we are comparing these two, so it has more minus I, so it is this. Fluorine and F3 plus acid, we have to just compare the negative I effect of these two, first, second, and third. Here also alkyne is first, then it is second, then is all I am is applying the negative effect on this acidic part. On here, if somewhere alcohol is given, I'll applying over. Now these two questions, when the how it could be acid? It could be acid because it has 2H over here, it has 2H over here, and let's say it has somewhere 2H. Now these 2H, if we have a negative charge, these are stabilized with this 2 minus I effect, 1 minus I effect, and no minus I effect over here. So it will be 1, 2, 3, most minus I, then this, then this. Now let's do remaining problems. Let's talk acid of alcohol. We have alcohol cyanide, alcohol NF3 plus, and we have alcohol NO2, formic acid over OH. Then we have now here we are comparing just minus I effect over here. First minus I, second minus I, third minus I. Formic acid, acetic acid, and benzoic acid. The order is formic acid, then benzoic acid, then acetic acid. Now you will ask how it could be these two. Formic acid is greater than benzoic acid. There are a lot of explanation of this, but you have to remember that. Since you will say it is a minus I and it has zero effect, but why is still more? So you have to remember that it is an experimental data why formic acid is more than benzoic. You may all see a lot of explanation, but eventually you have to remember that. You won't be able to journalize that stuff. Okay, right. So here it is more minus less minus 1 second. In this particular question, you have a lot of alpha, beta, gamma, delta for acidic part, acidic hydrogen. You have to like arrange which is more acid. So OH delta, alpha, beta, gamma, delta. So F is more closer to beta, and so right, you may write this is actually, you may rewrite the question. Then actually C double bond OH. You could write. So alpha, beta, gamma, delta. You can see that alpha is more acetic acid, which is more than phenol on alcohol. Sorry, alcohol. Now second is closer to the beta. Sorry, fluorine. This is beta. Then gamma. Then gamma. Then delta. So that's how you can determine the acidic strength. Remember, acid will form a conjugate base and H plus. More the stable conjugate base eventually are anions. More the stable anion, more will be the acidic strength. If the anion is directly on the element which is different from the carbon, then you can identify the size. If size are approximate, then you can identify it by the electronegativity. But in second, when it is on carbon, then you can check it by with the help of stability of carbon ion, which we have seen in the application of intermediates of carbocation.